Hi and a very good day. So for this video session, I will demonstrate to you on Box-Jenkins model identification by using eViews. Right? Okay, so what will you learn in this video? Okay, I will show to you on how to plot the original series. Okay, to generate differencing series. Okay, and plotting differencing series, and also how we'll perform plotting parallelogram by using eViews. Okay, so suppose that we have these two data. Okay, actually you can open multiple work file in a single eViews. Okay, this is for a non-seasonal data set, and this is for seasonal data set. Right, so let's take a look first how the data looks like. All right, okay, so this is the original data set, okay, for non-seasonal. And right, okay, this is the original data set for seasonal. Okay, how can we know for sure that this is non-seasonal and this is seasonal? Okay, first let's do some plotting towards the original data series. Right, so this is the plotting for non-seasonal. As we can see here, right, it is a linear trend, the upward trend, and of course when there is trend, okay, the data set is not stationary. So what about the seasonal data series? Okay, suppose that we project the line graph here. Okay, as we can see here, okay, they actually have the peak period at the same time. Okay, so this is right 12, 24. Okay, so basically this is a monthly data series, right? 36 and so on. Right, so we know that, okay, because they have the same pattern at the same period. Okay, it is a sign that this data series is seasonal data series. So of course when we want to do Box-Jenkins model, okay, we have to make sure that our data series is stationary. Okay, so let's take a look at the parallelogram for both data set. Okay, when you open, okay, you click view and then you go for parallelogram. Okay, there the window here will make you to choose whether you want to plot at level. It means that you for the data set that you chosen here is non-C, okay, without differencing it. Okay, or the first difference of our data set. What happen if we perform the first order difference towards the non-C data set here? Right, so but for this purpose, let's take a look at level first. Okay, so as we can see here, okay, for the ACF plot, as we can see here, okay, the autocorrelation value is slowly decaying, okay, towards 0 here, slowly decaying. It is a sign of non-stationary, and based on partial correlation value here, there is a significant spike at leg 1, which we can say that the data series can turn into stationary if we perform the first order differencing. Right, you also can project the parallelogram if you perform the first differencing by clicking this. Okay, so what happen if you do some differencing? Okay, it seems that it's still decaying but in a faster rate compared to the first original series. Right, okay, so maybe there we need to add AR and ME component in our modeling, okay, to make sure that, okay, the specification or the specification of Box-Jenkins model is fulfilled after this. But for this purpose, I just show to you on how to do some model identification, right? So let's take a look at our seasonal data set. Okay, right. So when I plot correlogram towards the original data series, what happened here? Okay, there is a wave-like pattern. Okay, wave-like pattern is actually a sign of a seasonal data set. Okay, and then there is a significant spike at the same period of lag here. Okay, so we can see lag 12, okay, lag 24, 36, right? So this is a sign that this data is a seasonal data set, right? So seems that we need to perform, okay, a seasonal differencing first before we proceed with modeling with Box-Jenkins modeling. I will show to you on how to generate the data series for if you want to generate differencing data series, non-seasonal data series, or for a season data series. So how can you do this? Okay, so here, okay, you make sure that, okay, you click quick and then generate series, right? So when you want to generate series for the first differencing of non-seasonal, as example here, okay, so I just do some name here, right? Okay, equals to, okay, in eViews, if you want to perform this differencing, okay, you just simply, okay, type D, and then what are the data series that you want to do differencing. Okay, suppose that here non-C, right? So I click OK. Okay, so now we have the first differencing of the first order differencing of our non-C data set. Okay, so when we plot the graph, okay, what you get, okay, now instead of a linear trend before this, okay, it seems that the data set is seems stationary. Okay, but you to be sure, you always can check, right, the unit root test here. Okay, so unit root test, okay, this is ADF, right? So click OK. Okay, so okay, we want to reject the null hypothesis to say that our data series has not have a unique root. It means that when you reject the null hypothesis, okay, our data series is actually stationary based on ADF test. Alright, so okay, it seems that, okay, the stationary requirement for this data set is fulfilled, but okay, you can check the correlogram at level. Okay, what happen if you check at level? It will give you the same correlogram as previous demonstration. Okay, but here okay, we can add AR autoregressive component or, okay, moving average component here, so that as we can see here, the probability of Q statistic here give you a signs of a not white noise. The residual is not white noise. So what we have here, you have to put some AR and MA component to make sure that, okay, the residual is white noise. So here, as from my reading, my ACF reading for the first differencing, okay, I know that, okay, seems that the ACF is okay, a faster decaying pattern, and you have a significant spike here. I will say I will add AR component, okay, maybe because there is only one significant spike here, I will add AR1 in my model after this, but I will show to you how to model Box-Jenkins in the next video. Okay, this is just for some model identification. Okay, the ACF decaying in faster rate, okay, until leg 6. After leg 7, the ACF is not significant. Okay, and then for PACF, one significant spike. So I might consider to add AR1 in the model after this. Okay, so how can we project the first seasonal differencing? Okay, so now let's do our focus to seasonal data set here. Okay, so this is our seasonal data set. So what we do is, right, okay, what we do is to generate series for seasonal differencing. Okay, you click quick generate series. Okay, cdiff. Okay, just example. Alright, instead of we still use D to make the EViews recognize that we want to do differencing. Now, okay, sys, but for seasonal, okay, you need to add a little bit specification in the bracket, right? 0 here means we don't perform the non-seasonal differencing toward our data set, and 12 here, it means that we will perform seasonal differencing for YT minus 12. Okay, if you quarter instead of 12, okay, you change it into 4. Right, so what we do, okay, we click OK, and you will get the series for after perform seasonal differencing. Right, so what we have here, okay, this is data set after we perform seasonal differencing. Okay, you can check the parallelogram. Okay, is it stationary? Okay, it's slowly decaying. Okay, to make sure, let's perform unit root test. Right, so based on unit root test here, okay, it seems that we might, the data series is stationary after we perform non-seasonal seasonal differencing. Okay, so do we need to proceed with non-seasonal differencing? Okay, actually based on ADF, we don't need to proceed, but if you want to do some non-seasonal differencing, so what you do is, right, you click quick, okay, generate series, okay, non-C diff equals to D sys. Right, now we will do non-seasonal differencing and seasonal differencing. Okay, right, so you will have here, okay, if you plot the graph, what happened, okay, it is better than the previous graph. Okay, and it seems that it fluctuates around 0. Okay, but it depends, maybe we can consider to perform non-seasonal differencing, or you might not want to perform non-seasonal differencing. Okay, but for the model selection, you can add both. Okay, and we will do some model estimation and validation after this to know which model is better than the others. Okay, so based on our seasonal difference, when we perform the first level, as we can see here, ACF is decaying at until like 8, and this is a sign of you need to add some AR component. I will say two significant spike, so I will add AR1 AR2 in the model. Okay, so if we want to read the coloregram for after we perform non-seasonal differencing, as we can see here, there is there is 1, 2, 3 significant spike for ACF and 2 significant spike for PACF, which is ACF is for the MA order, PACF for AR order. Okay, how many AR you want to add, how many MA you want to add, right? So here 3 or 2 significant spike, this is 2 significant spike. Okay, so maybe you want to add MA1, MA2, MA3, here AR1, AR2. Okay, so that's it for model identification. Okay, so actually now, okay, I have shown to you 2 example. Okay, first for non-seasonal, and second one is for seasonal data set, right? So I hope that you understand how to do model identification for both data set, right? So thank you for watching and listening. See you again. Bye.